Good day, everyone. I want to quickly simplify this problem. Simplify 25 raised to the power of 2 over 3 divided by 25 raised to the power of 1 over 6. Then everything divided by open brackets, everything divided by 5, close brackets, raised to the power of minus 7 over 6 times open brackets 1 over 5, close brackets, raised to the power of 1 over 6. Now, how are we going to? Now, the first thing I want you to realize is that I always talk about indices is about breaking down and this and that. Well, the numerator now, if you check the numerator, you discover that the base are the same, 25. But you can still decide to say, okay, I want to break down the 25 because I love breaking down. So I want to break down the 25 before applying the division. Now, what should we do? Well, let's say we want to break down. Let's say we want to break down because you know it's going to be 5 raised to the power of 2. You know that. So I'm going to write 5 raised to the power of 2. But you know that there's 2 over 3 as the power before. So meaning that you're going to put your bracket 2 over 3. Then you put your division. Then you have 25 of what? 5 raised to the power of 2. Then which is brackets 1 over 6, the power that was there before. Then everything divided by 1 over 5. I'm going to rewrite 1 over 5. Somebody is going to say something like this, that, well, that 1 over 5 has a negative power. Why is it that minus, that is the minus? Well, I would say no, don't do that here. Don't do that here. The reason is that I'm going to show you soon. So now we have 1 over 5, then raised to the power of minus 7 over 6. Multiply 5 raised to the power of 1 over 6. Now, the reason why I said you shouldn't do that here was because look at this 1 over 5 here. 1 over 5 here is the base. Please note that in indices, a fraction can be base, please. So just like you have 2 raised to the power of 2, then let's say you have 2 raised to the power of 3, the 2, well, let me write it. So if you have 2 raised to the power of 3, then this 2 here is the base and this is the power. Now, our base is whole number. But you can have maybe 3 over 2, everything raised to the power of 5. Then this 3 over 2 here, this 3 over 2 becomes our base. Now 1 over 5, and you can see that the base here is also 1 over 5, 1 over 5, meaning that you can apply the law of multiplication of indices with this multiplication. So if you use the minus to change this upside down, then the base will be different, will not be the same thing. So that's why I'm going to be very observant whenever I'm simplifying any problem. So here, I'm not going to change this to 1 over 5. I'll remove the minus. I'll keep the minus there. So now, here now, what's the next thing to do? Then I'll open the bracket or that 2 times, because bracket means times, 2 over 3. Then I'm still going to put the division sign there. That's going to be 5 raised to the power of what? 2 times 1, 1 over 6. Yeah. Then everything divided by, well, look at the denominator now. I can apply the law of the same base, which is 1 over 5. So I'm going to write my base to be 1 over 5, everything raised to the power of what? Then the first power here is minus 7 over 6. I'm going to write that. So let me write that. That's going to be minus 7 over 6. Then multiplication here, this multiplication here means addition. So I'm going to write plus. Then the second power here, this second power is 1 over 6. So I'm going to write 1 over 6. 1 over 6. Well, I think we can continue the problem over here. Then the numerator here, let me simplify. Well, here nothing can divide, so I'll just say 5 equals to 5 raised to the power of what? 2 times 2, that's 4 over what? Over 3. Then divided by 5 raised to the power. Of course, here you discover that 2 can go 2 here, 1. 2 in 6 is going to give us what? It's going to give us 3 here. Of what? 5 raised to the power of 1 over what? 1 over everything divided by what? Now, everything divided by the base, which is 1 over 5. Then I will simplify this power here. 6 plus 1 over 6. I'm going to simplify this. Of course, I know that the LCM is going to be 6 because in addition of fraction, you're going to find LCM. So you're going to say 6 here. So 6 in 6 is 1. 1 times minus 7 is going to give us minus 7. Then plus, because you have plus here, 6 in 6 is 1. Then 1 times 1 is going to give us 1. So what I'm trying to say is that when you find the LCM 6, then you rule over it. 6 here in 6, 1. 1 times minus 7, minus 7, then plus 6 in 6, 1. 1 times 1 is 1. So that is what we have done there. So the next thing is that we are going to say minus 7 plus 1. A lot of people don't really know how to do this. I don't know. Please, in mathematics, anything minus is you are owing. You are owing 7. Then plus 1 means I am having 1. So if I'm owing 7 and I'm having 1, at the end of the day, I'm going to be owing because I'm owing 7 and I'm having just 1. So when I pay, I'm going to be owing what? 6. And because owing means minus, so you say I'm owing 6. So that's going to be minus 6. So then divided by 6. So 6 here 1, 6 here 1. So 6 cancels 6. At the end of the day, we have minus what? Minus 1. So everything up here is going to give us minus 1. So and that's why here I'm going to write what? I'm going to write minus 1 here. I'm going to write minus 1. Let me clean this. Then the next thing I'm going to be doing now is that I am going to continue. That is, I'm going to division to the numerator because the division in between them. Look at the division in between them. This division is in. We're applying the law of division. So I'm going to pick one base because bases are the same. That's why I can apply the law. So 5, I pick one base. The first power is 4 over 3. And don't forget, division means minus and not plus. So you say minus. The second power is actually 1 over what? 1 over 3. Then everything divided by. Now, I want us to do a little bit of simplification down also. The reason is that look at the negative power here now. So you can easily apply the law of negative power here, which is 1 over 5 raised to power minus 1. So the minus, if you want to remove the minus, then you turn the base, which is a fraction, upside down. So instead of 1 over 5, I'm going to turn it to 5 over 1. And that's what I'm going to do. So I'm going to say 5 over 1, then everything now raised to the power of what? 1. Somebody will say, where did the minus go? Well, we have used it to turn this base upside down. So now let me simplify the numerator of the the power of the numerator somewhere here. So now look at it. We have 4 over 3 minus 1 over 3. Of course, this is a fraction. In fraction, we find LCM. You know, we don't just subtract. Well, the base are the same. The denominator of the fractions are the same, and you can do that. But I will not still say you should do that, because somebody will still say 3 minus 3, which is not like that. So find the LCM. The LCM is going to be 3. Then we rule over it. Come back. How many 3 am I going to see in 3? 1. 1 times 4, 4. Then your sign is minus. How many 3 am I going to see in 3? 1. 1 times 1, 1. So that's what is 3 in 3, 1 minus 3 in 3, 1. 1 times 1, 1. So I'm going to have what at the end of the day? That's going to be 4 minus 1 is going to give us what? It's going to give us 3 over 3. And 3 over 3 is going to give me what? It's going to give me 1. So meaning that the power here, the numerator, is going to be 1 at the end of the day. So I'm going to just copy the 1 because I've done the calculation here. So now, let's say I'm going to have 5 raised to power 1. My numerator is going to be 5 raised to power 1. Everything divided by the denominator also. You know, 5 over 1, anything raised to power 1 is that thing. So 5 over 1 is actually 5. The denominator, anything divided by 1 is that thing also. So what I'm trying to say is that here 5 over 1 is 5. Then the power, well, should we put the power again? Well, let's put it. Then everything is going to give me, let me just write like this. It's equals to 5 raised to power 1 is 5. Then divided by 5 raised to power 1, the denominator is also what? It's also 5. And then 5 divided by 5 is going to give me Thank you.